All right. In the following questions, two of which will be on your test tomorrow, or questions like them. It says here that the measures of three sides of a triangle are given, and it says to use the triangle inequality to find all possible values of x. The triangle inequality says that any two sides of a triangle have to add up. Their sum has to be greater than the third. And so that's what you have to do in all these exercises. You have to set up those three inequalities, and you have to solve them, and then find the values of the restraints on x. And what I mean by that, let's just take question number 1, for example. Let's just make a triangle. Let's label the vertexes A, B, and C. Let's let AB be 3, BC be 7, and AC be x. The triangle inequality says that any two sides, their sum, they have to add up to be larger than the third. So in that case, AB plus BC has to be greater than AC. That's one possible scenario. Okay, the second would be the sum BC plus AC has to be greater than AB. And the third and final would be AB plus AC has to be greater than BC. So if you look here, we have side AC, AB, and BC. We've taken into account all possible scenarios. From here, you just plug in the corresponding values. AB is 3, BC is 7, has to be greater than AC is x. Here, we can combine like terms. 10 has to be greater than x, or x has to be less than 10. So in order for this to be true, in order for AB plus BC to be greater than AC, AC has to be less than 10, and that should make sense because any two sides have to be, their sum has to be greater than the third. 3 plus 7 is 10. Okay, so if x was 10 or anything larger, this couldn't be a triangle. The best we could do is connect them end to end in a straight line. So in this case, x has to be less than 10. Down here, we have BC plus AC. BC is 7. Plus AC, which is x, has to be greater than 3. Well, x is referring to the length of a side of a triangle, and length or distance can't be negative. So we know right here that 7 plus anything positive is going to be greater than 3. And if you were to solve this, what you would end up with is x has to be greater than negative 4. This would have to be true in order for this particular inequality to be true, but in the case of lengths and sides of a triangle, x couldn't be negative anyway because the length can't be negative. So maybe we could say x has to be greater than 0. But in this case, this inequality is probably not going to be used because if you look here again, any value of x is going to make this true, at least any positive value of x. But we do have to solve the third inequality. And the third inequality says AB, which is 3, plus AC, which is x, has to be greater than BC, which is 7. Subtract 3 from both sides, and x has to be greater than 4. Because if x was less than 4, for example, 3, we would have 3 plus 3 is not greater than 7, so that wouldn't work. That's why it has to be greater than 4. Even if it was 4, 3 plus 4 is equal to 7. Again, the best we could do is connect those in a straight line. So what we see here is that x has to be less than 10, and it has to be greater than 4. So any of those values would work for x. And that's how you use the triangle inequality to find all of these possible values. You do the same thing for 2, 3, 4, 5, and 6. 6 is more difficult. Not much more, but a little more. So really you need to concentrate on 1 through 5 because the questions tomorrow will be similar to these. Okay? If you want to look and say, well, why don't we use that one? Again, if x is greater than negative 4, that would work for this scenario, but values greater than negative 4 wouldn't satisfy this. Remember, all of these, they always have to be true. Any value of x has to be able to be plugged in for any side. So in this case, we're going to use this one, and we're going to use this one, and that's how you answer question 1 on the 5.5 practice for the test.